So in Unit 4, we did exponential functions. So we talked about exponential growth, decay, compound interest, and simple interest. So this is our regular formula for any kind of exponential growth or decay. These two are for interest only, so money questions. If you don't have money questions, I don't need to use these. So this is compound interest, this is simple interest. I will know that I'm using either the compound interest or simple interest formulas, again, if I'm dealing with money, and if the words compounded or simple appear in the question, I can decide between the two of them. If I see compounded, of course I'm going to use compound interest. If I see simple interest, I will use the simple interest formula. Otherwise, I'm defaulting to this formula. Okay? So let's go over a couple different examples here. We have a bacteria that can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. For example, if we start with only one bacteria, which can double every 2 hours, how many would be present at the end of a day? This is a straightforward, classic exponential type question. So this is just literally like figure out y, a, b, x, plug them in, calculate, and you're good to go. So I'm going to use that y, a, b, x formula. B, because we are doubling, will be 2. We are starting with one bacteria, so that's the initial value A. X has 2 components to it. It's total time t, which we don't know. Actually, we do know. End of 1 day. So total time is 1 day. And it doubles every 2 hours. So that's the doubling period. That's what goes on the bottom of X. The future amount of bacteria is unknown. There is a problem here, however. I can't have a unit in days and a separate unit in hours. These need to be in the same unit of measurement. So 1 day, I'm going to switch that to 24 hours over 2 hours, which gives us 12 for X. So within that day, 12 doublings have occurred. That's what X really is. How many times has the growth or decay happened within your given time period? So we're literally just going to plug this right into the y equals a times b to the x formula. And we'll plug it into our calculator, making sure that we're doing bed mass. So you do 2 to the exponent 12 first, and then you can multiply. I mean, we're multiplying it by 1, so it's not really going to change once we do that. And we should get 4096. And then for all of these, we do a therefore. So therefore, at the end of 1 day, there will be 4,096 bacteria. Okay, I'll let you guys just kind of fill that in. But don't forget about that interpretation of your answer for these types of questions. Okay, let's look at an exponential decay. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So of course, we could probably figure this out pretty easily just by doing like a sequence of, okay, after the first round, there's 64 people. After the second round, there's this many people. I think we probably could do that in this question. I'll show you how you could use the formula for this, but of course, you guys can probably just figure this out by guessing and checking. But again, I'm going to use that A, Y, A, B, and X formula because I'm not dealing with money. I start with 128 participants. That will go in for A. If the players are being halved, I'm going to plug in B as a half. 5 rounds have passed. That's kind of like, this one's slightly different because it doesn't have to do with time. So this is going to be like total amount of rounds that have passed. So 5 rounds. And half of the players are eliminated each round, after each round. So this would be over 1 round. So at the end of 5 rounds, 5 halvings have occurred. That's basically what we're looking at. And why is the question mark? So again, very straightforward example here. We're just going to plug in and calculate, making sure that we follow BEDMAS rules. So exponents first, and then you can multiply by 128. And I'm getting 4. Okay, so therefore after 5 rounds, 4 players remain. This is like the odd scenario out where we don't have time. Instead, it's like rounds that have happened. Okay, here's probably the example that we all want to kind of tune in for, which is how to use log, if you don't remember how to do this. So this one's a little bit more complex. An element decays rapidly with a half-life, I'm going to underline that, of 10 minutes. I'm going to underline that too. A sample is taken initially and there is 40 grams of the element. I'm going to underline that. What time was the second sample taken if there was 4.3 grams left when it was taken? Okay. What time? X is usually the variable that represents all the things to do with time. So I'm probably looking for some part of X here. I have an initial amount of this element of 40 grams. I know at the end, when the second sample is taken, there's 4.3 grams remaining. I also know, because I see half-life here, that the amount of the element is being halved. So B will be half. X has 2 parts, total time, which we don't know how much time has passed from the initial sample to the future sample, so I'll put T. And half-life period, or growth or decay period. In this case, half-life takes 10 minutes, so this will be 10 minutes. I should expect at the end that I will get out my time in minutes because this is entered in minutes. If I wanted my time out in seconds, I could change 10 minutes into seconds, and then I'll get my answer out in seconds. Okay, so let's plug into that same formula again. I know as soon as I see an unknown in the exponent that I'm going to have to use log on my calculator, right? So the first thing that we need to do is get the base and exponent isolated, alone on one side. So I'm going to divide out 40 on each side. And if you happen to get an exact value when you do 4.3 divided by 40, you can write the decimal. If it's a repeating decimal that fills the entire screen of your calculator, leave it in fraction form. This one is literally just 0.1075 and then it stops. So we can round. We don't have to do any rounding, so we can keep that in decimal form. I will then come and log both sides now that the base and exponent are alone. And I apply something called power rule. We talked about how you can bring this down in front as a multiple when you take the log of something with an exponent. So again, you'll talk about that more in advanced functions if you decide to take that. But we're going to bring it down as a multiple. And then we'll just start to move everything away from t. So if I'm multiplying by the log of a half, I will divide that out to get it to the other side. These will cancel, and then t over 10. Notice that I'm not rounding or calculating anything in my calculator until I get to the very end of this, because I don't want to keep, this is like a big thing in exponential functions, is like if I keep rounding my answer from line to line to line, then eventually my whole answer is going to be off in the end. So I leave things as exact as possible until the very end, and then I can go and put it into my calculator. So I'm just going to multiply 10 up on each side. And if you have a calculator handy, you can try this with me, entering this into your calculator. So 10 log of 0.1075. If your calculator opens a bracket here, right here, it is super important that you close this bracket up before you divide by the log of a half, or 0.5. Okay, if we've done this correctly, we should get out 32 point, let's go nearest hundredth here, so 32.18 minutes, as we mentioned above. Okay, so therefore, 32.18 minutes have passed since the initial sample was taken, or whatever you want to say. Okay, feel free to stop me anytime if you guys have questions or anything that needs clarification. Okay, and then compound interest, I might just like slightly tweak this question for, this will be a part A, and then we'll do a part B on this. So compound interest, how much should you invest at a rate of 5.6% interest per year compounded annually if you want to have $10,000 in 5 years? So compounded, it's a money question. It says interest in there. Sophia? Did you close your bracket here before you divided? And you multiplied by 10? I'm guessing maybe you're just entering something in incorrectly. This is 1 over 2, right? Or 0.5? Okay. Okay, so I'm going to use that compound interest formula with A, P, I, and N. This is what the formula looks like. Ella, can you actually just shut that back door fully there? It's just kind of loud. Do I know the future amount here? Abby, what is it? Pardon? 10,000. We want to have 10,000 after 5 years. How much should you invest now? I don't know. That's the question. I, interest rate as a decimal divided by number of compounds per year. If this is compounded annually, that's divided by 1 compound per year. So I will stay as 0.056. N is number of years, so 5 years, times number of compounds per year, which will always match this number here, which is 1. So at the end of 5 years, I've compounded my interest 5 times. That's what N is. So let's plug in. I think this was similar to a test question that we did, or maybe some versions of the test had this. The easiest way that you can isolate for P here is just to divide this entire thing out. I would do it all at one time. So I'm going to divide out, maybe we'll even just simplify inside here, 1.056 to the exponent 5. And then I'm literally just going to enter that exact thing into my calculator here. That way these cancel. I haven't done any extra rounding or anything like that. And I should get an exact answer here. So 10,000 divided by, in brackets, or I guess it doesn't have to have brackets, 1.056 to the exponent 5. I'm getting 7,615 and 18 cents. Okay, and then you'll say, therefore, you should invest $7,615.18 now in order to have 10,000 in 5 years. Sam, can you just close that back door for us there? Okay, what if I change this scenario? It's 5.6% interest per year, but now compounded monthly. How do the values above change out of A, P, I, and N? What do we need to alter? I still want $10,000 after 5 years. So that will still be my future value. I still want to figure out the present value. I have to now take that 5% interest and split it up equally over 12 months. So I need to take 0.056 and divide it by the number of months or compounds per year. And if this gives me a repeating decimal, which it does, I'm actually just going to leave it like this in my formula. And then at the end of 5 years, if I compound 12 times a year, I will have actually compounded my interest 60 times. So I have to take that number of compounds and multiply it by the number of years. So basically, I'm just going to have what we rearranged here. It'll be 10,000 divided by, and then we'll just put in our new values for I and N. So this would be a good thing to practice entering into your calculator. You could kind of like calculate this first, possibly, and then just do 10,000 divided by answer in your calculator. But if you'd like to try this and just make sure that you can get out the correct answer, that might be good. I'm going to do it in my calculator quickly now as well. And then you just double check that you can get the correct answer with mine. Okay, Okay, you should be able to get an exact answer, like exactly the same thing. So I got $7,562.76. I would suggest maybe you calculate this, add 1 to it, put it to the exponent 60, and then divide that into 10,000. You can kind of do it piece by piece in your calculator. Okay, and then you would say, therefore, in order to have $10,000 in 5 years, when it's compounded monthly, I would be investing $7,500 instead of $7,600. About $50 difference. Okay. If we change this to simple interest, we have to remember that the simple interest formula only gives us out the interest part, so it won't add the principal onto the value. So I would say if I wanted, actually we couldn't really do this version of the question because I wouldn't be able to figure out what that principal is. So we couldn't really alter this to be a simple interest question. I would have to give you the principal, the rate, and T is always just time in years. So yeah. I think I would probably more likely focus on compound interest because it's exponential on the exam rather than focusing on simple interest. Just so you know, okay? So that's basically the end. That kind of goes over each type of question that we did. Other than transformations, we did do transformations of exponential functions, which I actually have a couple little questions on here. So we went over the key points of both of these. We can take a look at how we would see transformations in a function if it's together. So I might actually just switch this. Let's go f at x equals -3, 1/2. And maybe we'll do 2x plus 4 minus 5. Okay, so this is transformations. You will see transformations of exponential functions in this format. So it will look like this, where you have a and c on the outsides. You'll have the base function, which I'm going to indicate the base with b. That tells you what your parent function is. And then you'll see k x minus d up in the exponent here. So this tells you that your parent function is b to the x. It's not a transformation. And one other thing that we need to remember for all transformations is that k must be common factored out of x and d, which in this case, this format is not quite right. So before I start doing transformations of this, I would want to ensure that I take out that 2. So I would write it like this. And then I could identify transformations from there and do the transformations of my parent function point. So I have an a of -3. I have a k of 2. D is -2. And c is equal to -5. So in our previous lesson, we went over the base parent functions of half to the x. I'm not going to do this full question, but if I were to do like actual transformations of the parent function, okay, this half part is telling me that the base function is half to the x. I would just choose like -2 to +2 for any exponential function. That should give you some points on the left and right of the y-axis. You plug them in for x here, and then you just do transformations as usual. So along with the horizontal asymptote at y equals 0. So as we plug in each of these, I believe we get 4, 2, 1, 0, and half. Or no, sorry, 0.5 and 0.25. And then if I were to set up my equations here, I would do reciprocal of k plus the d value, so the one that I already switched the sign of above, and then ay plus c or minus c, whatever you have. We would do our points, and we always remember that the horizontal asymptote will shift up and down with our c value. So our new horizontal asymptote for this one, once we do our points, is at -5 because we shift down 5 with the c value. Okay, I think you guys could probably go from there. So take each of your x's, half them, subtract 2. Take each of your y's, multiply them by -3, subtract 5, and then just create your graph with your horizontal asymptote on there. Okay, that's pretty much everything that we did from exponentials.